first slide, just going to bring you really into this unit. Who remembers what we need to look at before we convert these things?
Usually perfect squares. So it's somewhat depends on the indexes.
Yeah. So you want to look at the perfect square chart or the perfect cube chart. It depends on your index. Did use a term there. Remember, your index is the little number that's right there. So whatever that is, that's the chart you're looking at. This one is a 2, so we need to look at the perfect square chart, which means when you're doing these questions, I'm not going to give you a chart. Liz, how can you give us a chart? Yeah, she's a lot nicer than I am. I'm not going to give you a chart, so you just got to make your own on the side of the paper. So 2 squared equals 4, 3 squared equals 9, and you're going to do a few of those every time you do one of these questions until you get so good at them that you just really stop using them all together. That's kind of the purpose of not giving you the chart, is you'll just get good at it, and then you won't need the chart anymore. You'll just be able to do it automatically. Okay, what do we use that chart for? Yeah, we want to find the largest one of these that factors into that number. 16 is the largest one. So we would take the square root of 32 and we would rewrite it to be the square root of 16 times 2. Because 16 times 2 is just 32. We didn't change anything. Didn't do anything crazy. Remember that rule I made you guys star that one slide that told you the square root of a times b is equal to the square root of a times the square root of b? That's where it comes in handy. Because now we can just separate these two things apart from each other. So it becomes square root of 16 times the square root of 2. Whatever your perfect square was, because you use the perfect square, you should be able to square root it. What's the square root of 16? 4. 4. So your answer is just 4 times the square root of 2.
I'm just like wondering, or not so much wondering, I just forgot why
Why is the 4 out here? Because, that's a good question. Because you got the square root of 16 times the square root of 2 right here, right? Can you change the square root of 2 to anything? No, so we can't do anything to it, so we just leave it alone. So what is the square root of 16? 4. So the 4 is on the outside because it's still 4 times 2. Like that never changes. 2 separate things times each other. Does that make sense? Right.
Is there a happy number that doesn't like go into one of these? Like you use the bigger one?
So if you had like
no, like none of them go. Yeah.
None of them go in, then you can't do anything. So like the square root of 37. There's no number in here that'll divide into 37. So it just, the simplest form would be the square root of 37. Think of it as simplifying a fraction. If you can't get it any lower, you just leave it, okay? So 1/2 is already in simplest form, so you wouldn't have to simplify it anymore. Same idea.
So you just leave it at 16 times 2 things.
In this one?
Yeah. Like if there's the 37 one, you just leave it like that.
Yeah. Yeah. Hope that's all reviewed. Yeah? Okay. This is an example of exactly what you were just asking. Okay? So square root of 33, that thing can go into it. That is simplest form. Right below it, they've broken down and neatly shown you what to do to the square root of 18. Where did the number 9 come from? How did they know to go 9 and 2? Yeah, because 3 squared is 9. And then 9 times 2 is 18. So they made their little chart. Their perfect squares for 4, 9, 25, so on and so forth. They figured out 9 can go into it. At the very bottom is our little rule again. Remember that rule? Okay. Keep on going. What if the index is 2? And I think Ty kind of alluded to this. What do we do if the index is 2? What changes? Jason? Use the cubes. Yeah, exactly. So because this index is 3, we need to use the perfect cube chart. So you go 2 to the power of 3 is 8. 3 to the power of 3 is 27. 4 to the power of 3 is 64? 64. Is it 4 to the power of 3, 64? Someone checking their calculator.
Yeah.
It is Ken. Yeah, so if you look at the inside, can 64 go into 56? Obviously not. Can 27 go into 56? No. 8 can go into 56. Jason did it 7 times 8. So we make it the cube root of 8 times the cube root of 7. The cube root of 8 is 2. So you just change it to 2 times the cube root of 7. That would be simplified all the way. Notice that I started from the bottom and went up. Now yeah, that was in my head too. So we started here and went up. It's kind of a way of protecting yourself. Because if you go from the top to the bottom, you might use one that's too small. So for instance, if you had a number that both 64 and 8 would go into, and you use 8, you wouldn't be simplifying all the way. You would just be partially simplifying. If you start at the big numbers and go to the top, then you're good.
Would there be a way, like, if you prefer to use 8, would there be a way to get it to equivalent?
Yep. So what you would do is you would simplify it again. So you would get to this point, and you would take your cube root of 7, and you would simplify it one more time. So it's just more work. Yeah. So you might as well start with the big numbers and work your way through. It's not wrong to do it the other way. It's just a longer way of doing it, and I'm lazy and always take shortcuts. So go big number to small number. Okay, on the bottom, you should do those on your own. Those 4 give you a couple minutes. They should be pretty quick. The 4th roots, make the chart on your own. Nope, so if you don't know how to make the chart, in your calculator, just go 2 to the power of 3 is 8. So to make the 4th chart, you would go 2 to the power of 4 is equal to something. Should be 16. In your calculator again, you go 3 to the power of 4 is equal to, and you build your own chart. Yeah. No, let's do that. No, sorry. It's already recorded. Yeah, I'll run. The first one, the square root of 54, what does that simplify to? What'd you get, Jacob? You got an answer? No? There's an answer. Julie, what'd you get? Square root of 54. Did we get 3 times the square root of 6? Anybody get something different? Okay. Part B. I'm going to do C as a group because I think we still could use a little refresher. But B, what did you get for an answer? Ty? 2 cube root 12. Anybody get anything else? C, we'll do together because it's got a trick to it, it's got the negatives. So if you look at your perfect cube chart, 64 goes into 81, nope. 27 goes into 81, yep. So what does 21 go in? How many times? 27. 3 times, right? So you should have the cube root of 27 times the cube root of 3. Where's the negative go? Does it go with the 27 or does it go with the 3? 3? 27? Does it matter? Really doesn't matter. If you put it with the 27, that's fine. You put it with the 3, that's fine. What is the cube root of 27? 3. So you have 3 times the cube root of 3. And again, if you put the negative in front of the 3 here, that's okay. And if you put the cube root or the negative in front of the 3 in there, that's okay. The answer will work out the same. As long as you remember that that negative has to stay, and it can only stay in one of them. It can't be in both of them. So this 3? Yes. Number or letter D, I guess, is already simplified. Nothing can go into it. Nothing goes into this one. The division property was, this is where you're talking the whole time. The division property, basically the exact same thing as the multiplication property, is just division. So if you have the square root of a fraction, you can break that up into 2 different square roots. Pretty simple concept. It's the exact same thing as multiplication. The way we broke 2 multiples up, you can break 2 division sides. Yeah, a fraction. So if you look right here, it's the root of a fraction. Yeah, a divided by b. You can just change it into the root of a divided by the root of b. So you just break that. Better just actually than just talk about it. Write this as a mixed radical. First step, fractions suck. They always suck. Get rid of them. So the way we're going to try to get rid of this fraction underneath the root sign, because that's even more difficult, is we're going to use our little rules. So we're going to go cube root of 40 over the cube root of 81. Yeah, so where's the negative going to go? Either one. You can pick either one. I'm going to pick 40. I usually let it stick with the top. But it doesn't really matter. Okay. Now, what do you have? You have a radical on the top. You have a radical on the bottom. What do you think you're going to do? Simplify them both separately. So if you had just the cube root of 40, you could simplify it. So do that. If you had just the cube root of 81, you could simplify it. So do that. We're going to need our cube chart. 2 cubed is 9. 3 cubed is 27. 4 cubed is 64. No, we're not going to need to go here. 4 cubed is...
2 cubed is 8.
Oh, sorry. Thank you. Does 8 go into 40? Yeah, I skipped 27 and 64 because they obviously don't. So what is the 40 going to change into? 8, 5. So we got the cube root of 8 times the cube root of 5. And on the bottom, 81. 27 goes in. Yeah, so you're going to have the cube root of 27 times the cube root of 3. Now you want to simplify one step further. What is the cube root of 8? It's 2. So on the top you have 2 times the cube root of 5. On the bottom you should have 3 times the cube root of 3. And the negative, yeah, because it was up here with the 40, the negative can stay with the 8 or the 5, which means that down here it can be with the 2 or the cube root of 5. Yeah, so it'll be good. You can literally have a negative on any of these 4 things and you'd be good. As long as it's just one negative. Okay. Easy enough, wasn't too crazy, right? Okay. Try them on your own. Try all three. See how you do. If we're looking at this first one, I'll show you guys, I'll finish the debate for you. This first one, a lot of you guys did the first step right, and you got it to the square root of 125, and then you got it to the square root of 4 still on the bottom. When you see the square root of 4, so I saw you guys do a lot of different things with the square root of 4 on the bottom, and none of them were really wrong, technically. But the way you're going to see it in answer keys, so for multiple choice and stuff like that, they're just going to simplify it right away. What is the square root of 4? 2. So they're just going to write 2. It's not 2 times the square root of 1. And some people even broke it up the square root of 2 times the square root of 2. And that's kind of the right track to think. You just got something a little backwards.
So you still have to simplify it even though it's in fraction.
Yeah.
Okay, that's where that is.
On the top, the square root of 125 would change into the square root of 25 times the square root of 5. The reason we chose that is because 5 squared is 25.
So there's a perfect square.
Yeah, like you break it apart like I did, but then instead of putting square root of 4 on the bottom, you can just change it to a 2 right away. And then you're done dealing with anything. Yeah, man.
Okay, so I wrote down like the first one and I got like 5 square root of 5.
So you got the square root of 5 times the square root of 25? Okay, that's not wrong, that's right.
No, but I didn't get in that order. I got like the square root of 25 times 5, so I kept the 20, or I kept the 5 and square
And
root
that's-
of the 25 to put
yeah.
it in front.
That's the second thing most people have been doing. So a lot of people are knowing that the 25 came from 5 squared. But they're actually getting rid of the wrong root sign. And there was a lot of you around the room when I was just walking that I saw did that. And you wrote this out. And this is not correct. You wrote out 5 times the square root of 25 divided by 2. That happened all over the room. Happened a lot last year too.
That's not
This is supposed
That
to be
is wrong.
five.
I'm going to show you why. If you're if you're ever in doubt, explain. I'll talk you through. If you're ever in doubt about if you're right or you're wrong, just punch it into your calculator. So, for instance, put in your calculator right now the square root of 125 divided by 4. And tell me what you get. Okay, CJ, what'd you get?
5.590.
Okay, now take this one over here and punch it into your calculator. So the square root of 5 times the square root of 25, all divided by 2. And if you punch that in your calculator, you'll get that it's equal to 5.590.
Yeah. Exactly.
Now, Jason.
Is it like that? It's like, let's put the 5 back in now. Maybe 25 times 25.
Yeah, which is way off. Yeah, that's a good way to know. Now punch this one into your calculator. 5 times the square root of 25, all divided by 2. And tell me what you get. Should be a significantly larger number. 12.5? When you guys are doing math and you're using an equal sign, that means things have to stay equal all the way through. It's not just like a placement to tell you that you've moved on. It actually is meaning everything always is the same. Once it changes, is where your mistake is. So if you're not getting the right answer, you can actually work your way backwards to figure out where you went wrong. Okay, the reason this one is wrong is if you took the square root of 5 and put it in your calculator, you should get some crazy decimal. 2 point something, 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 something. If you put the square root of 25 into your calculator, what do you get? Just 5. Anything that can be put into your calculator and come out as a whole number, that's what you're changing and getting rid of. So the correct answer would actually be 5 times the root of 5. And the reason for that is this right here connected with that 5 right there. This 5 right here, because you can't change it, stays with that 5 over there. Does that make sense? Is that cleared up?
Gotcha. So like if it's like a perfect,
Okay, we'll do one more.
no, I'm trying to, so if it's like a perfect square, a perfect cube or something, you just drop, like, bring it right down.
Right.
Sorry.
Yeah. Hey, these are hard, so I get it. Let's do B as a group. Because B is a tricky one. First thing you want to do, you see a fraction under a root sign, and you're simplifying, break it up. Yeah, get rid of the fraction underneath the root sign. That's the worst part. So you got the 4th root of 32 divided by the 4th root of 243. And now you're just simplifying 2 things, just separately. What chart do we need? 4th chart. 2 to the power of 4 is what?
16.
3 to the power of 4 is what? 4 to the power of 4 is what? Thank you. Use your chart. See what breaks up. Is 256 going to go into either of these numbers? Definitely not. Does 81 go into 32? No. Does it go into 243? Yes. And those of you who are like, how did you know that? I didn't know that. Take your calculator, go 243 divided by 81. And I literally test everyone just like that. I don't know how these things memorized. Just punch in your calculator. 3. Okay. Okay, the bottom is simplified part way. Now to the top. 32 and 16 obviously work out. So it's going to be the 4th root of 16, and you're times it by the 4th root of 2. Now is the part that people were confused about. On the top, what can simplify? 16 can simplify. Hi, Sonny. For someone? Okay. That's okay. The 4th root of 16 changes to be what? 2. The 4th root of 2 changes to be what? Nothing. Stays the 4th root of 2. And if you ever wonder if it's going to stay or not, in your calculator, the 4th root of 2 is crazy decimal. Crazy decimals are no good. So that's what you have on the top. 2 times the 4th root of the 2. On the bottom, which one of those is going to simplify, Maddie? 81. And what's it going to become?
It's going to become 3.
You got it.
And it'll be like
3 times, and the 4th root of 3, you can't simplify. Put it in your calculator, it's crazy that you can't simplify that. So it's just going to be the 4th root of 3. That would be your answer. I'm going to do the 3rd one quicker. I'm just going to talk through it. So you're just going to have to check with your own work. Ask a question if you have a question. Okay? We're doing cube roots. So we need our cube chart. 2, 3 is 8. 3 cubed is 27. 4 cubed is 81. 64. Good call. Thank you. Okay. I'm going to break these apart. So I've got cube root of 64 on the top. On the bottom, I've got the cube root of 81. The negative, I'm going to leave it on the top because I just usually do that. I'm going to look at that right away. Cube root of 64 sticks out to me because there's a 64 right here in my chart. Cube root of 64 can already be simplified, so it just changes to become negative 4. I'm leaving the negative on the top, so it stays with that 4.
Well, how do you choose that?
Pardon?
You don't have to put that under like a root sign? No.
No root sign. And why, Julie, why is there no root sign?
Oh, because whatever's,
Yeah, because the cube root of 64 is 4. So the cube root went away. I used it. Emily. Okay. On the bottom, 81 simplifies using which number? 27. So I've got the cube root of 27 times the cube root of 3. That simplifies to be 4 over 3 times the cube root of 3. Negative 4.
Question.
Yeah.
It's for the first question, actually.
Okay.
Because I got 2 4.
On the bottom.
It's difficult to get to the fourth question.
Yeah, I'll go back and check in a second. We're going to let these people go out to this question, I guess, and it's probably a simple thing. Hey, things are about to get a lot harder. That was all review stuff. Yeah. So, yeah, this is what we're about to get into, so you probably want to pay close attention. We're now going to start using variables, meaning letters, instead of numbers. On the bottom is a nice little example that you can always refer back to. I'm going to lift it up a little higher so you guys can see what I'm pointing at. On how to do these questions. The way that they recommend doing it is like this. I think this probably is the easiest way, but I'm going to show you another one that's kind of more in your head. So if you're understanding what's going on, it's a little quicker. Okay, what they say to do is you take your index. So your index of this first question is 2. They say break everything up into groups of 2. So 25 in 2 groups would just be 5 times 5. A squared broken into groups of 2 would just be A times A. In case you're lost on why that is, A squared is just equal to A times A. B broken into groups of 2 would be what? B. It can't be broken into groups of 2. That's what we're going to get to that. Because it's never going to work out evenly. It's going to always be kind of messy. You then, for every group of 2 that you have, you're going to have 1 on the outside of the root sign. So if you're looking at this, how many groups of 5 do I have if they're broken into 2s? I have 1 group. 1 group of 2.
Yeah, that looks pretty.
1 group of 2. So that 5, just 1 of them comes out. The A's, how many groups of A's do I have if they're broken into 2s? 1 group of A's, so that's right there. How many B's are left over? How many groups of B's were there? 0. So there's 0 B's outside of the root sign.
So there's never anything inside if they're in a
Right. All the groups get brought outside. All the non-groups stay inside. Okay, we're going to see a couple more questions. I'm going to keep going slowly. Maybe I'll answer some questions as we're going. Can I show you the way it is in your high? Okay. If you look at example 11, square root of 81, sorry, the fourth root of 81, p cubed times q to the power of 5. What am I going to want to break these into? 4. So can you break 81 up into 4 things that are all the same that multiplied together would work out?
3.
Yeah. You can break 81 up into 3 times 3 times 3 times 3.
You want to make groups of 11 in there.
So, yeah, that's a good question. We're going to get to some examples. All the what-if situations, we'll get there. 81 breaks into 4 3s. P to the power of 3. How many groups can we break that into? 0. There's no groups of 4. You need 4 in a group. Otherwise, they just stay underneath groups. There's no groups of P's. Because P to the power of 3 is the same thing as P times P times P. And if I need 4 in a group to create a whole group, is that possible? No. K, Q. How many groups of 4 can I make out of Q if there's 5 of them? One group of 4 and 1 on the outside, right? They wrote it just like that. Q to the power 4, that means there's 4 Q's, and they left the Q on the outside. Are you this last time?
Yeah.
Okay, beauty. Grab a seat. Use a note package. We're on 1.2. Okay. This second step.
What do you do if you can't reduce it in 4 weeks?
It's confusing because people keep talking.
Why would they break down the keys? Like, why don't they just
You could so Aaron said a really good question. Aaron's saying, why did you write it as 3 times 3 times 3 times 3 instead of just 3 to the power of 4? That's a great question. You could just write it as 3 to the power of 4. It's just as easy. In fact, I think it's easier. So I'm with you. It's the exact same thing. But it's easier to look at the group of 4 like that.
But then the key confuses me that he's the size.
Yeah.
So why is it different? They should have same rule.
Yeah, they did it with the numbers because it's easier to see with numbers. But the letters, they couldn't have done it for all of them, or we would have run right off the page. I want to show you guys. I want to ask Logan's question in a second. But Logan's got a question first, but you guys are being just terribly rude. Logan, go ahead.
Oh, say if there's like 7 Q's, so you just take the 4 and then put like the 3 on the outside.
Yeah, the 3 would be left over. So, we're not done. Let me go through the lesson and then ask you questions. Because we've got so many what-if situations that would be answered if you just have patience. If you look at this first one, there's one group of 3, so that came outside. There's one group of Q, so that came outside. Everything else that's left over that's not in a group of 4 stayed underneath the 4th root sign. Right there. We'll do a question together, so it's a little bit easier. This is stuff you can make sure to do. I'm going to walk you through it so you can see what I'm talking about. Hold all the questions, even from your friends, until the end, okay? Okay. This first question. We're doing a square root, so I want to break things into groups of 2. The 4 on the outside is freaking out people just looking at it. All it means is 4 times all this mess. The 4 is pretty irrelevant till the end. Just leave the 4 on the outside. It's going to be 4 times and then all this mess, and we're going to deal with that later. Okay, we want to break things into groups of 2. Can 24 be broken into 2 things where if they multiply by each other, it would give you 24? 12 and 2 are not the same number, right? That would be 2 different numbers making a group, so that doesn't work. Can you do 3 times 3? No. Can you do 4 times 4? No. Can you do 5 times 5? No. And we're beyond 24, so that means there's nothing that's going to break into 24. So leave 24 alone. This is how I like to do it. You might want to follow this little pattern. The index is 2, right?
Yeah.
Okay, can you shut the door for me? Thank you. What I'm going to do is I'm now dealing with my A's. I'm going to count up by 2. So, A to the power of 2. How many A's do I have? 2. I'm going to do it again. A to the power of 2. How many 2's do I have? 4. A to the power of 2. How many 2's do I have? 6. How many are left? Only 1. So I'm just going to leave it as A. I'm going to do the same thing with my B's. How many B squares am I going to have? Just the 1. So it should be B squared times B. Counting up by 2's because that's what the index is. How many C's am I going to have? 2 of those. You can see that's a little bit messy, but that's alright. 24, I can't do anything with, right? We already talked about that. Gotcha.
I just want to know, I'll just have to like break that down to the model.
No, we have broken it down. I just broke it down using a different method. So, like, you mean breaking it into all
Like
A's?
24, no.
Oh, we can't break the 24 down. And because the 4 is outside of the square root, we don't want to break that one down either. Because you're right, we could have broken it into 2 and 2. But because it's outside the root sign, we leave it alone. That's a good question. I didn't think of that. What's the square root of A squared? A. So that's why all your things come out as 1s. So this A squared is going to give you just 1A. This A squared is going to give you another A. And then another A. And then you can't do anything to the square root of just A. So it's going to stay on the inside. So right now we have pulled. I'm going to underline the things that I'm pulling outside of the root sign. Which is just 8. Yeah. What else can come out? The B squared can come out. And both C's can come out. And if you're looking at that and going, why didn't we just write C squared, A cubed? Yeah, that's what we're going to do. You can do that right now if you want. I'm just going to go a little bit slower the first time so that it's a little more automatic. What's left underneath the root sign is all the things we couldn't bring out. So 24, A, and B.
We just keep it 4.
And the 4 is still in the front. Now, you would simplify it the way you guys want it. So it's just 4 times A cubed times B times C squared times the square root of 24AB. And you can see these are getting really big and they're getting kind of tough. And where you're going to see questions with this stuff is we're going to give you triangles and squares, and we're going to have to find missing sides, but we're never going to give you a side length. So you're going to have side length X and side length Y. So A squared plus B squared is equal to C squared, and then you're going to be having all these square roots, right? It's going to be kind of crazy. So doing this stuff and understanding this stuff is essential to where we're headed. And I know a lot of you are looking at it, your eyes are just saying, like, what the heck is happening? It's okay. We got some time to work on it. Okay? I'm going to do this next one again. If you're terrified, that's all right. You're going to do okay. The second one. What am I going to count up by? What am I going to, like, I'm going to walk through. Oh, the 4 is still up there. So it's just 4 times. Okay. If we look at question B, what group sizes do we want to break this into? 3s. So if you like breaking them into individuals, do 3s. When I say break them into, I mean I like to count up by 3s. So I'm going to go cube root and 56 is broken into. What can be broken into? 8? 8 times 8 would be 64. 4 times 8, it would be a really big number, right?
Oh, two.
You can't break it down, maybe.
So she says, could we not do 2 to the power of 3 times 8?
No, because
Or times 7?
you have to have a repeat.
Yeah, I put it Julie's right.
Because it's the same as splitting up in 4.
Okay.
This is
Why? I know, why?
it was so easy to
I know. That's why we need to do it together. 56 is the same thing as 8 times 7.
But you need a group of 3.
Right.
So 2 is a group of 3.
But then 8 can be broken into 2 times 2 times 2. So there's your one group of 3. And your extra is that 7. So remember when we were breaking up 4 peas? And we had an extra one? Same kind of idea. The numbers don't all have to be beyond the same after you've done your one group. Okay, it would help if people weren't talking around us. So Josh, Dawson, let's listen up, okay? Because I guarantee you, when you get a test question like this, you're going to leave 56 alone. And I guarantee you, that will be a multiple choice answer. It's a promise. And it's wrong. Hi. Yeah. Okay. If you're having a hard time seeing that 56 can be broken into 2 cubed times 7, what you can do is take 56 and try to think of different factors that make up 56. I'm not going to give you massive numbers for this stuff. It's going to be smaller numbers. So you can figure out 56 is equal to a lot of things times each other, right? You can figure out it's 2 times 28. Or you can figure out it's 3 times, 3 doesn't work. You can figure out 4 times something. 4 times 14, right? And eventually you'll get to 8 times 7. And there's numbers in that need to be kind of just automatic recognizable. 8 is one of them. It's a perfect cube. Right? So you need your perfect cube chart. You need to remember those numbers. Yes, sir. 4 times 4 is 16, times 4 is 64. Close, close.
So why didn't we do 2 squared times 6?
On 24? We could have gone 2 times 2 is 4 times 2 is... Yeah, we could have broken that up. I didn't see it. Yeah. We could have broken 24 up. Yeah. Don't sweat A. Don't worry about it. You got the hard part right. What we wanted to show you there was the letters, because you've never done letters before. Don't worry about the number. Now I want you to stress out the number on B. Hey, it's what you need to be able to do. It's all about. How many are you going to take out of A to the power of 5?
1.
Just 1. 1 and 1 and then you split.
Yeah, so Liam's got it. So if you're looking at your A's, there's an A cubed, and then there's an A squared left over. If you're looking at your B's, how many can you take out? 2 B cubes. So you can go B cubed, B cubed. How many of the C's to the power of 7 can you break out? 2 and 1 left over. See, you guys are getting it. You were freaking out last time about this.
Well, it's just that beginning part.
Yeah, the first couple of times seeing it, and the numbers, trust me, you'll see it and they'll be easy. Just, you gotta see it through a couple times.
Wait, you can put 8
Okay, hand up.
Yeah, look at your spots.
Hand up.
Well, it's not said to be for this. You said it's 2 by 2.
Right, just So what's left over?
So you put the two keyboards.
Just
So I-
leave it that, put it in there.
Yeah, you just leave it as a square.
Anything with through that matches your index will be canceled out, and that's why it comes out the back.
Yes, that's why it comes out. So what he was saying was, these things are coming out of the brackets because you're able to cube root them. The cube root of a cubed is just a. He said it in a fancy way, but he's right. So that makes sense. You're right. Okay. What's the cube root of 2 cubed? 2. What's the, I'm going to underline things I'm taking out.
Cube root.
What's the cube root of a cubed? A, so that's going to come out. What's the cube root of b cubed? This one? C. So if you do all those cube roots, they all come out as just individuals. So it comes out as A, and then you have 2 B's, which is just going to be B squared. You have 2 C's, which is just C squared.
And then inside,
And then what's left inside?
7, and then it times a squared times c.
You got it, man.
Magic.
You don't have to write your times in the answer, you can just write them side by side. And that would be it.
Wow.
That's
We're not done this lesson.
we all get
Yeah, because there was 2 that came out. Okay. We're still not done. If you're feeling confident and you're like, this stuff, like I get it. I want you to try and answer this question. If you're stressing and you're like, Kennedy, you're speaking different language right now, pull out your practice booklet, start on your practice booklet where we left off.
Okay.
Yes, I'll give you a practice booklet. And Ryan, I'll get you a practice booklet. Now, we'll do this. Maybe to start off tomorrow, or maybe when we're done everything.